Hello, it's time to review for our estimation, factors, and multiples unit test. Let's begin. Number 1 asks you which is the closest estimate. We know, based on our vocabulary words, that estimate means I need to round. I need to round the 58 and the 22. So here's what you do. In your workspace, take 58 and 22 and place them on top of each other so that you can see my highest shared place value is the tens. And those are the numbers that get underlined. And then you circle the number to the right, following Mr. Panza's rounding rules. Step 3, sing the chant. This 8 is a 5 or above, so I give the underlined number a shove, plus 1, which means the 5 turns into a 6, and then step 4 tells me that anything circled into the right becomes a 0, and you'll be all right. I round the 22 the same exact way. Step 1, underline. Step 2, circle the digit to the right. That's the boss number. Step 3, 4 below, leave the underlined number go. That's singing the chant. So that 2 remains a 2. And step 4 is anything circled into the right becomes a 0 and you'll be all right. Which means I am estimating the product of 60 times 20. And in this case, that's choice D. I don't even need to find the actual product. I just need to know that I'm rounding 58 and 22, and eventually I would multiply. The next one you need to solve. What is the estimated product? Well, I need to take 416 and 6, and first I need to round and then solve. So in this case, I do the same exact step for 416. I'm going to round it. But I do not need to round the 6 because it is just a single-digit number. So when I have a single-digit number, I drop that right into my math equation. But I do have to round any multi-digit number, which is 416 in this case. Step 1, underline the highest place value. Step 2, circle the digits to the right. Step 3, using this one directly to the right, I'm going to sing the chant. 4 below, I leave this 4 go. And then the next step tells me that anything circled into the right becomes a 0. And you'll be all right, which means 400 times 6. The great thing about this test is you can plug it into the calculator, and when you do 400 times 6, you get 2,400. So my answer to number 2 is 2,400. Question 3 is testing for divisibility. The students have a process for this as well. Let me show you how you can test each of these numbers for divisibility to find out which statement, A, B, C, or D, is incorrect. Letter A wants to see if 2 is a common factor of both 24 and 72. So using a calculator, you can test for divisibility by taking the larger numbers and dividing them by the number you're trying to see if it's a factor by. In this case, 24 divided by 2 gets me an exact whole number of 12. And if I get an exact whole number, in other words, I don't get a decimal or I do not get a remainder in my calculator, that means that 2 is a factor of 24. The same can be said for 72. As I take 72 and I divide it by 2, I get an exact whole number of 36 without a remainder. And the only time that you can say that 2 is a common factor of both of these numbers is if both of them come out as exact whole numbers. So in this case, the answer is yes. 2 is a common factor of both 24 and 72. So A is not the correct response because we are actually looking for the incorrect answer. Just to make the quiz a little bit harder. So let's check out B. Can 12 and 39 have a common factor of 3? Well, it may look a little weird, but the answer is actually yes. Let me show you how. 12 divided by 3 gets me an exact whole number of 4 without a remainder. And 39 divided by 3 also gets me an exact whole number of 13, which means that 3 is also a common factor of both 12 and 39. So in this case, that is correct. So my answer can't be B because we're looking for the incorrect response. I'm not going to finish this one. I'd like you to use your testing for divisibility skills and try C and D to see if you can come up with the correct answer. Go ahead and try it now. Now that we've moved on, you want to check out number 4. 4 asks you, what is the sum of the first two multiples of 6? Well, we recently had a lesson on multiples that reminded us when we talk about multiples, that word multiples, we should think of music. And that's because Mr. Panza has come up with skip counting songs for many different digits that will help us remember how to skip count. That music is our multiples. In other words, if I'm looking for the sum of the first two multiples of 6, I'm going to skip count by 6. However, I'm looking for only the first two multiples. So I'm going to sing those first two multiples of 6, place them on these lines, and then add them together because I'm also looking for the sum of those two multiples. So let's skip count by 6. 6, 12, then I stop because the question's asking for two multiples of 6. These are the first two multiples. I add them together, and whatever you get, that's your sum, because we know that the answer to an addition problem is the sum. In this case, 12 plus 6 would be 18, or letter C. Which pair of these numbers has 18 as a common factor? Well, if you want to find factors, you just need to do factor rainbows. And in this case, we know that every single factor of 18 is going to start with a factor rainbow of 1 and 18. That was the strategy we showed the students on how to find factors of 18, which means in this case, I'm not going to have to even check A and B because those are too small. 2 times 3 would get me 6, which isn't close to 18, and 2 times 7 would get me 14, which is closer, but still not 18, which means I need to see if these are common factors of 18 and if these are common factors of 18. In this case, I know that the answer is D because if I came up with a factor rainbow, I can use the strategy to see all of the factors of 18. Here's how. When completing a factor rainbow, I can place 18 as my product pot of gold number all the way on the right. That's step 1. Then I start with my LAMO rainbow, which would be for prime numbers, but every rainbow has at least one in itself in common because 1 times 18 would get me 18. Now I need to test and see if other numbers are also factors. For example, 2, 3, 4, 5, 6, 7, 8, and 9. And I'll know when to stop when the commutative property is present. So let's start with 2. Well, wait, we just talked about how to test for the divisibility of 2. I take the larger number, in this case the product pot of gold number, I divide it by the smaller number, we're testing to see if 2 is divisible, and it gives me the answer of 9. That tells me that 2 is a factor, and so is 9, because 2 times 9 is 18. Then I cross it out and move on to 3. How do I test for the divisibility of 3? I do 18 divided by 3 and get my answer, which is 6, which tells me that 3 and 6 are also factors, which means I can cross out 3 and 6 because I've tested them. How about 4? I do 18 divided by 4. Do I get an exact whole number? I do not, which means I'm done, because the next number that I would try would be 6, and like I mentioned, the commutative property is there, and I do not have to write 6 times 3 because it's already present, which means all of the factors of 18 are 1, 2, 3, 6, 9, and 18. So that tells me that D is my answer, because although 18 is a factor, 9 is a factor of 18, and 36 is not a factor of 18. Let's move on to number 6. It's a small word problem. Maddie bought 36 boxes of cookies for a holiday party. Each box holds 12 cookies, and this is the key part. What do you want to know? About how many cookies does Maddie have? So we're talking about a multiplication question, because if you have 36 boxes of cookies and there are 12 cookies in each box, if you multiply them together, you will get the exact actual answer. That's not what we're looking for here. We're looking for an estimated response, an estimated answer. So I need to round both 36 and 12 to the highest shared place value and then multiply. Same exact steps for rounding. 5 above, give the 3 a shove to a 4, Anything circled into the right becomes a 0 and you're all right. So 36 becomes 40 and 12 becomes 10 because 4 below, leave the 1 go, and now I have 0. Then take your calculator, do 40 times 10, and find your estimated answer of 400 cookies, or I really should say about 400 cookies, which means my answer is B. Question 7 is asking you for the actual product and the estimated product, which means the actual product is going to take 327 multiplied by 7. We want to know the actual answer. However, the estimated response is going to be when I round 327 to 300 and multiply that by 7. Because the 7 is a single-digit number, it stays the same. However, 327 gets rounded. Now I can just take my calculator. The actual answer, 327 times 7, I plug that in and I get the answer of 2,289. And the estimated answer is 300 times 7, which is 2,100, which shows you that your estimated answer is reasonable because 2,100 is fairly close to the actual answer of 2,289. Let's move on to the final question of the front page, and then you'll have to finish up with the second video right here at my website. For this one, we're looking for the sum of all the factors of 28. Well, we know to find all of the factors of a number, we use a factor rainbow, which we'll show you in just a second. After we find the factors, we're going to list them here, and rather than separate them with commas, we're going to separate them with addition signs because we're looking for the sum of the factors, and we know that sum means the answer to an addition problem. Let's do our factor rainbow to see if we can find all of the factors of 28 first. My first step to factor rainbows is taking 28 and writing it as my product pot of gold number at the end of the rainbow. Step 2 is starting with my LAMO rainbow, which is 1 and the product, because we know that 1 times 28 will get me 28. Now I need to test for the following numbers. I start with 2. How do I check for the divisibility of 2? I take my product pot of gold number, divide it by what is possibly a factor, and when I get my answer, that's the one that I connect the rainbow to. So 2 connects to 14 because it's an exact whole number. And then I can cross out 2 because I'm done with it. Now let's try 3. Take your product pot of gold, divide it by 3. That one doesn't work because I get a decimal or a remainder. The next number I try is 4. 28 divided by 4. In this case, it works because 4 times 7 would get me 28. I can cross out 4 and 7. I still want to try 5 and 6. So 28 divided by 5 does not work. 28 divided by 6 does not work. I'm done because 7 times 4 is the opposite, as we know, the commutative property, which means my factors are 1, 2, 4, 7, 14, and 28. Let's list them. 1 plus 2 plus 4 plus 7 plus 28. The reason I separate them with addition signs is because remember we're looking for the sum of the product, which again, take your calculator out and add them together to find the sum. 1 plus 2 plus 4 plus 7 plus 28 is the sum of all the factors of 28, which is 42. And that is how you complete the front page of our review for this test. Check out video number 2 to see the back half of the test review worksheet.